Good morning to one and all. I am Parthiban, working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. So I am going to talk about the unit 5, particularly about the uni-junction transistor, that is called UJT. UJT is a three-terminal semiconductor device that is having only one PN junction. Unlike BJT, it is not used for amplification. Instead, it is used mainly for switching and triggering device. The three terminals it has are namely emitter, base 1 and base 2, that is B1 and B2. Why it is called unijunction transistor? Uni means one. So the device contains only one PN junction between the emitter and silicon bar. The important characteristics are the three terminal device. It is a one PN junction device. It has high input impedance. It is having the negative resistance characteristics. It is very low cost and reliable. Excellent triggering device. These are the important features of our UJT. Next, we are going to see about the construction of UJT. So UJT consists of a lightly doped N-type silicon bar, two ohmic contacts at the end of that is called base 1 and base 2, B1 and B2, a heavily doped p-type emitter that is diffused in the n-type bar. So the emitter is positioned very closer to B2 rather than to B1. So the internal structure you see from the diagram, that is B2 n-type bar, then p-type emitter, then B1. So if no voltage is applied to the emitter, the current flows only through the n-type bar. The bar behaves as if like a resistor between B1 and B2. This resistance is called interbase resistance, that is RBB. So the RBB is nothing but the interbase resistance, actually, which is having the definition of RBB is equal to RB1 plus RB2, that is keeping IES equal to 0. So RB1 is the resistance from the emitter point to base 1. RB2 is the resistance from emitter point to base 2. So the typical value of this RBB ranges from 4 kilo ohms to 10 kilo ohms depending on the manufacturer. So the interbase resistance determines the peak voltage, the triggering condition, the oscillator performance. So the diagram shows the typical analogy, or we can say it is an equivalent diagram where a diode that is connected with the two resistors in the potential divider arrangement. This is the analogy or electrical equivalent of UJT we can see. Then coming on to the important performance parameter of that UJT is intrinsic standoff ratio. It is represented by means of eta. Eta is the ratio between the resistance between the emitter junction and the base 1 to the total base resistance. That is eta is equal to RB1 divided by RB1 plus RB2, keeping IE as equal to 0. So generally VRB1 will always be equal to VBB. So this is the important performance parameter of UJT, that is called intrinsic standoff ratio. Then coming on to the characteristics, or we can say the working of the UJT, we can see the characteristics having the three regions importantly. One is called cutoff region, the other one is called the negative resistance region, the third one is called saturation region. So in the x-axis we are having the emitter current, in the y-axis we are having the emitter voltage. So initially if B2 is positive with respect to B1, the emitter junction is reverse bias, no current, emitter current flows. When as VE increases, the emitter PN junction remains off until VE reaches the peak voltage. Once peak is reached, the emitter junction will become forward bias and the holes are injected into the n-type bar and the resistance decreases suddenly. This causes the large increase in the emitter current, a sudden drop in the emitter voltage. This phenomena is pronounced in the region that is called negative resistance region, that is shown in the diagram. So the negative resistance region is the important characteristic feature of UJT. So it is having the three regions of operation. Either it can be used in a cutoff and saturation as well as in the negative resistance region. Particularly, the UJT cannot be used as an amplifier because of this negative resistance region. Then coming on to the static emitter characteristics that we can say, the graph between the emitter voltage and emitter current is called emitter characteristics. The graph, as I already told you, is having a three regions of operation. So the important points that we have to note it are the peak point, the valley point, the peak current, the valley current. That also we have to note it down. So increasing voltage causes increase in current, but in UJT, the negative resistance region, once again the current increases, the voltage decreases. So that point you have to remember. So naturally, when the emitter receives a pulse, the emitter voltage rises, the emitter currents increases rapidly, the resistance RB decreases, the voltage across the emitter drops, the device enters into the negative resistance region. After the current reaches the valley point, the UJT again turns off and turns into cutoff region. This is the typical characteristics of UJT. Coming on to the applications of UJT, it is very widely used, particularly for triggering and timing circuits. The prominent application is UJT as a relaxation oscillator, which is very common for sawtooth waveform generation as well as for the timing of pulses. Then it can be used for SCR triggering. Then it can be used as a pulse generator. Then it can be very widely used in timing circuits such as delay circuits, electronic timers, as social sequential timer circuits. It can also be used as a sawtooth wave generator. It can be used for phase control circuits also. These are the prominent advantages are there. So applications, it has several advantages also there. It's very simple and manufacturing cost is very low, low power consumption, excellent triggering device, high reliability, stable operation. These are the primary features of UJT, why we go for. So in the disadvantages, we say that it is having the limited voltage rating, low power handling capability, it cannot be used as an amplifier. These are the primary disadvantages of UJT. So comparing with the UJT and BJT, we can say UJT can be used as more as a relaxation oscillator, whereas BJT can be mostly used as an amplifier. Generally, it is used in switching and power timing circuits, whereas our diode is used or BJT is used in amplifier and switching circuits. So once again, these are the various references I used to have for the slides. Thanking you one and all for hearing my lecture patiently. Once again, I am thanking you one and all. Thanks.